Hi there, this is an Algebra 1 video. It is Chapter 7, Section 7, and today we are discussing geometric sequences as exponential functions. And so, the first thing I want to tell you about a geometric sequence is that the first term is always non-zero. So non-zero means that it's not zero. Now it could be positive, it could be negative, it just can't be zero. Second thing, each term after is found by multiplying the previous term by what we call a common ratio, which we'll call R. And I'll explain that a little bit further as we continue in our examples. The last thing is that a common ratio can be found by dividing any term by its previous term. So the reason why I wanted to bring up the whole common ratio thing is because this is to compare it to a arithmetic sequence, which we did earlier in the year. And in an arithmetic sequence, you have what they call a common difference. So that means that you would basically subtract any term from the previous term, like 128 minus 256, 64 minus 128. And if they always had the same difference, we call that the common difference, and it was an arithmetic sequence. But now we're talking about geometric sequence. And a geometric sequence is found by multiplying, not adding or subtracting the same number, but multiplying the same ratio to each term. So again, you can find the common ratio by dividing any term by its previous term. So in example 1, it says, determine whether each sequence is arithmetic, which would be a common difference, geometric, which is the common ratio, or neither. So in part A, what we want to do first is we're going to test out the option for a common ratio, which means if I can take 128 and divide it by 256, I take the term and divide it by the previous term. I can also take 64 and divide it by 128, and then take 32 and divide it by 64. And if these three ratios all give me the same number, then we're good to go. So 128 divided by 256 is 1/2. And 64 divided by 128 is also 1/2. So far so good. And 32 divided by 64 also 1/2. So in this case, because all of the terms had the same common ratio, then this is going to be a geometric sequence for part A. So when it says to explain, you can explain that it's a geometric sequence because it has a common ratio of 1/2. The ratios are constantly 1/2. Okay, so then we try the same thing with part B. And we take 9 divided by 4 and 12 divided by 9 and 18 divided by 12. So 9 divided by 4 is basically 9/4, and 12 divided by 9 is 4/3. So this fraction reduces to 4/3. 9/4 doesn't reduce, but you can see they're not the same ratio, they're not constant. And then just to make sure, 18 divided by 12 gives you 3/2. So you get 3 different ratios for each of those fractions. So basically this is not geometric. So then the next thing we want to try is to see whether or not it's arithmetic. So in an arithmetic sequence, you would have a common difference. So you would say 9 minus 4. 12 minus 9 and 18 minus 12 would be the 3 differences that you'd be looking at. But again, 9 minus 4 gives you a 5, 12 minus 9 gives you 3, and 18 minus 12 gives you 6. So you don't get the same difference every time. This is not arithmetic, it's not geometric, so you would put that it's neither. And as far as your explanation goes, you just explain that it doesn't have a common ratio, doesn't have a common difference, therefore it's neither. Alright, so now I want you to try, do it yourself number 1. There are 3 different sequences. So again, tell me if it's geometric, arithmetic, or neither. Okay, another thing that you can do with a geometric sequence is to find the next 3 terms in each sequence. Now in this case, we know that they're geometric. It tells us in the directions that it is geometric. So our job is to find that common ratio and then use that common ratio to determine the next 3 terms. Pay really close attention to when they tell you how many, because sometimes people just get this wrong because they only give me 1 term or they give me 2 terms. Make sure that you give as many terms as it asks for. So in this case, it's asking for 3. So we're going to take negative 4 and divide by 1, 16 divided by negative 4, and negative 64 divided by 16. Now in each of these scenarios, you're supposed to get the same common ratio, so I'm just checking. Negative 4 divided by 1 is negative 4. 16 divided by negative 4 is also negative 4. And negative 64 divided by 16 is negative 4. So our common ratio is negative 4. That means that I can multiply each term by negative 4, and that will give me the next term. So 1 times negative 4 is negative 4, and negative 4 times negative 4 is positive 16, and positive 16 times negative 4 is negative 64. So now what I want to do is take negative 64 times negative 4, which is the common ratio, and my next term will be 256. And then I take that times negative 4 and get negative 1024. And then lastly, take that times negative 4 and get 4096. So the next three terms in the first sequence are 256, negative 1024, and then positive 4096. So we do the same thing for part B. And so I'm going to take 3 divided by 9, 1 divided by 3, and 1/3 divided by 1. 3 divided by 9 is 1/3. And of course, 1 divided by 3 is 1/3. And 1/3 divided by 1 is 1/3. So again, my common ratio is 1/3, which means that I can take each term and times it by 1/3. So 9 times 1/3 is 3. 3 times 1/3 is 1. 1 times 1/3 is 1/3. And then we take 1/3 times 1/3. 1/3 times was 1/9. Sorry, my calculator gave me the wrong answer. 1/3 times 1/3 will give you 1/9. And then 1/9 times 1/3 is going to give you 1/27. And then finally, we're going to get 1/27 times 1/3 is going to give you 1/81. Okay? So basically, if you don't know how I did that, I'm taking 1/3 times 1/3. So that's going to be 1/3 times 3, which is 9. That's how I got the 1/9. And then 1/9 times 1/3 is going to give you 1/9 times 3 is 27. And then 1/27 times 1/3 is going to give you 1/81. Of course, I did it with the calculator, but you can see there how that happened. So I get my three terms that way. So now I want you to try do it yourself number 2. And then we will go on to our formula writing here. So in the next example, so our last example here, is how to write the formula for a geometric sequence. So again, this is the formula for a geometric sequence. We had one for an arithmetic sequence in the past as well. But basically, I just want to tell you what all of these variables represent. A sub n represents the nth term. So if this says a sub 7, and when I say sub, it's like subscript, like a smaller script. So a sub n, so if I put a sub 7, it means it wants the 7th term in the sequence. So for example, over here I have negative 6 is the first term, second term, third term, fourth term. So right now, a sub 4 is the 4th term in the sequence. And the 4th term in the sequence is 1, 2, 3, is 48. So the value of the 4th term in the sequence is 48. But each number has a placeholder. This is n equal to 1 because it's the first term, n equals 2 because it's the second term, n equals 3 because it's the third term, and so on and so forth. So be very careful that you understand what it means when it says a sub n. It means the nth term. And then a sub 1 would mean the first term. So that it represents the first term. R is the common ratio, and we already said that n is the place, the nth term there. So it says over here in example 3, write an equation for the nth term of the sequence. They want me to take this sequence and write the formula for it. So we're going to put a sub n is going to equal a sub 1, so it's going to equal the first term. And in this sequence, our first term is negative 6. And then we're going to multiply that by our common ratio. And we don't know where our common ratio is yet, but we can find it out very easily by taking 12 divided by negative 6, negative 24 divided by 12, and 48 divided by negative 24. And these should all have the same constant ratio. So 12 divided by negative 6 is negative 2. And negative 24 divided by positive 12 is also negative 2. And 48 divided by negative 24 also negative 2. So it turns out that our common ratio is negative 2. So I'll put that in parentheses there. And then we're going to raise it to the n power minus 1. All right, so that's basically your formula right there. There's not really any simplifying that you can do. If you were hoping to do something like that, you cannot, because I said before, you don't want to multiply these two first. That would be improper PEMDAS. You want to do the exponent first, but since that's a variable right now, we can't really simplify it any further. So this is the formula that they're looking for. And now in part B, we're going to use that formula to find the 9th term of the sequence. So we want to know what the value of the 9th term is. So that means that right here, a sub n, we want to know what a sub 9 is. What is the 9th term? So we have 1, 2, 3, 4. And we have to go 5, 6, 7, 8, 9. So one option is to keep multiplying by negative 2 like 5 more times. But that just gets tedious. You want to actually use the formula to solve part B. So that means we're going to take the negative 6 and then times negative 2. And then the n is 9. So we're going to go 9 minus 1, which is actually 8. And then just solve this little guy. So we're going to remember PEMDAS first. So negative 2. And make sure you put the negative 2 in parentheses. So negative 2 to the 8th power is going to give you 256. And then that times negative 6 will give you negative 1,536. So it turns out that the 9th term of this sequence will be negative 1,536. So now I'd like for you to do this last do-it-yourself question, and once you have completed this question, then you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.